practical is determination of platelets count. Significance of this practical is in order to diagnose thrombocytopenia, that is decrease in platelets than the normal range. Platelets are related with the clotting of blood. If platelet number is decreased, then the blood clotting would be affected and there would be more loss of blood at the site of injury. And then in order to diagnose thrombocythemia, that is increased platelets. So if number of platelets are increased than normal range, then there could be clotting within the blood vessels. So that could be damaging for the cardiovascular system. Apparatus that is required for this practical is hemocytometer, lancet, disinfectant, microscope, and ammonium oxalate solution for dilution of the blood. Number of platelets are about 0.15 million to 0.4 million per millimeter cube, so they are less than RBC. So we have to dilute this blood less as compared to RBCs. For RBCs we diluted blood up to 200 times. For this we dilute blood up to 20 times. So we'll use this micropipette that is actually for WBCs. We have to take blood up to 5 parts, and then we'll take ammonium oxalate up to 11 parts. So this whole would be diluted up to 20 times. So here we see the dilution factor. Final volume divided by the original volume, that is the volume of blood, and then this comes to 20 times dilution. So after diluting like we did in RBCs, we have to put this blood in new bar chamber, and for this we make a drop and bring it at the junction of cover slip and the new bar chamber. So the blood will diffuse between the cover slip and new bar chamber. We already know the description of new bar chamber. Again, we see the whole volume of this chamber is 0.9 millimeter cube, because it is 3 millimeter wide, 3 millimeter length, and it is a little depressed as we said previously, 0.1 millimeter. So volume of this whole chamber is 0.9 millimeter cube. So there are total number of large square equal to 9. So there are 9 square in this whole chamber. Volume of one large square, when we calculate, that is total volume of the chamber divided by number of large square, that are 9. So it comes to 0.1 millimeter cube. So one large square has a volume that is 1 millimeter cube. Platelets, they are smaller than even RBCs, so we have to count these cells in the central square. This central square is again divided into 25 small squares. Number of small squares are 25 within this large square. So volume of one small square is volume of one large square divided by 25, that is 0.1 millimeter cube divided by 25. Volume of this small square comes to 0.04 millimeter cube. So we have to count platelets like we did RBCs in these 5 square, that are 4 corner and 1 central. So the volume of the 5 small square is equal to volume of one small square multiplied by 5, that comes to 0.02 millimeter cube. So volume of these 5 small squares is a total 0.02 millimeter cube. Here enlarge this square here. This central square is lined by 3 wall boundary, and then we have to count platelets in the corner cells and central cell. If the platelets are present on boundaries, then we will count only those that are present in upper and the right side of boundary. We will not count those that come on the left and lower boundary. Now we are going to count these platelets actually in our experiment. For this practical we have hemocytometer, new bar chamber, and cover slip, micropipette to dilute blood for counting platelets. We have lancet, cotton swab, and the ammonium oxalate in order to use as dilution solution for platelets. We have microscope and a counter in order to count the number of platelets. We have taken blood up to 0.5 parts and then ammonium oxalate up to 11 parts. Now this blood is diluted 20 times. We are keeping it for 10 minutes and then we are going to load it in the new bore chamber. We are going to count platelets in the central square as we did for the RBCs. Under microscope we counted number of platelets in 5 small square or 143 total, 31 in first square, 36 in second square, 24 in third, 29 in fourth and 23rd in fifth, and they make a total 143 platelets in 5 small squares. So volume of these 5 small square, as we know, is 0.02 millimeter cube. Therefore, 0.02 millimeter diluted blood contains 143 number of platelets, and 1 millimeter cube diluted blood contains 7,150 platelets. So 1 millimeter cube concentrated blood contains 7,150 multiplied by dilution factor, and we know the dilution factor for platelets is 20. We diluted blood for 20 times. 0.5 was the blood volume that we took, and 11 parts was the total volume. So it was dilution factor was 20 times. So we have to multiply 7,150 with 20. It comes to 0.143 million platelets in 1 millimeter cube of concentrated blood. We see the number of platelets were lower than the normal range of platelets per millimeter cube of the concentrated blood. That is the end of this practice.